Hi everyone, greetings of the day. We are from Narayana Central Office, R&D, Max Department. Welcome to today's session. In this session, we are going to discuss 8th class, 6th chapter, squares and square roots. The subtopics of this chapter: 6.1 Introduction, 6.2 Properties of square numbers, 6.3 some more interesting patterns. There are some more subtopics: adding triangular numbers, numbers between square numbers, adding odd numbers, a sum of consecutive natural numbers, product of two consecutive even or odd natural numbers, some more patterns in square numbers. 6.4 Finding square of a number. There two subtopics: other patterns in squares and Pythagorean triplets. 6.5 Square roots. There four subtopics are there. First one is finding square roots. Second one is finding square roots through a repeated subtraction method. Third one, finding square roots through the prime factorization method. The fourth one, finding square roots by division method. 6.6 Square roots of decimals, and the last one, 6.7 Estimating square root. Coming to the introduction part, we oftenly heard that word square. Generally, in paddy fields or in lands, how much of land you have means I have some square meters of land, 100 square meters of land or 20 square meters of land. Like that, we are oftenly using the word square. Whereas coming to the separate topic of a squares and square roots concept, what is the basic knowledge is required to get the perfectness in squares and square roots? The pre-class knowledge. If the students are perfect with the factors and the multiples, then they will understand this chapter and solve the problems easily. Let us recall about the factors and multiples. A factor of a number is a number that divides the given number evenly or exactly, leaving no remainder. Let us take the example 12. The factors of 12 are 1, 2, 3, 4, 6 and 12. If we divide 12 with these numbers, we will get exact quotient without a remainder. And the factors of 16 are 1, 2, 4, 8 and 16. So here also we'll get factors without remainder. Now multiples. A multiple is the product result of one number multiplied by another number. Suppose 5 is a number. If you multiply 5 with 1, we'll get 5. 5 with 2, we'll get 10. 5 with 3, we get 15. 5 with 4, we get 20, 25, 30, so on. And multiples of 12 are 12, 24, 36, 48, 60, so on. If we observe the factors and multiples, factors are finite. And multiples are infinite. Remember that factors are finite and multiples are infinite. Whereas coming to the factors, itself is the highest factor and 1 is the least factor. Coming to the multiples, itself is the least multiple and does not exist the highest multiple. Now, check 4 more examples of factors of 12, 16, 24 and 36. The factors of 12 are 1, 2, 3, 4, 6, 12. For the 16, 1, 2, 4, 4, 8, 16. For 24, 1, 2, 3, 4, 6, 8, 12, 24. For 36, 1, 2, 3, 4, 6, 6, 9, 12, 18, and 36. From that above examples, two numbers 16 and 36 are expressed as a product of equal factors. See, 16 we are going to express as a product of 4 into 4. The same 36 also is possible to express the product of same factors 6 into 6. Now, if the number is expressed the product of same factors itself two times, then such type of numbers are called perfect squares. So, this is the definition of a square. If a number can be expressed as the product of two equal numbers, then the product is called square of the given number. Or in mathematical statement form, if m is equal to n square, square that is in notation, n power 2. M and n are natural numbers, then m is called square number. So here m I am going to express as a product of two factors n into n. That I represent with n power 2. In exponent we need to write the 2. And these are some examples of perfect squares: 1, 4, 9, 16, 25, so on. 1 square is equal to 1, 2 square is equal to 4, 3 square is equal to 9, 4 square is equal to 16, 5 square is equal to 25, so on. So we know there are infinite natural numbers, so obviously infinite square numbers also. And some note points. The square of an even number is always an even number. So in objective they'll ask the question, square of even number is dash. Odd, even, sometimes even, sometimes odd, data not sufficient, like that. You can take an example. Here I am taking example 4. 4 square is equal to 16. 16 is an even number. If you want, you can check with one more example. Similarly, the square of an odd number is always an odd number. So 5 square is equal to 25. Here I am taking one example. The square of a prime number or a composite number is always a composite number, because 3 square is equal to 9. 3 is a prime number. 9 is a composite number, because 1 and 9 are the factors of 9. Along with that, 3 is also one of the factor. And 6 square, 6 is a composite number. 6 square is equal to 36 is also a composite number. The next point, the square of a positive number or a negative number is always a positive number. I am taking example 7. 7 square is equal to 7 into 7, that is equal to 49, and minus 7 whole square is equal to minus 7 into minus 7, that is equal to 49. So square of a positive number or a negative number is always positive number. Now, second subtopic, properties of square numbers. Now, the square number cannot end with digits 2, 3, 7 or 8. So, the square numbers cannot end with the digits 2, 3, 7 or 8. Let us check this table. 1, its square value is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square is 100. If we check all these squares, the numbers are end with digits 1, 4, 5, 6, 9 and 0. So no number ends with 2, no number ends with 3, no number ends with 7, and no number ends with 8. So square of a number does not ends with the digits 2, 3, 7 or 8. So now the second point, the perfect square numbers can end with the digits 0, 1, 4, 5, 6 or 9. But remember that a number ending with these digits need not to be a perfect square. Suppose a number 27. We know 7 is not end with 7. 26 is not a perfect square, but it ends with 6. So the second point is the most important one. The perfect square numbers can end with the digits 0, 1, 4, 5, 6 or 9, but a number ending with these digits need not to be a perfect square. The best example is the 14. Yes, it ends with 4, but it is not a perfect square. 26, it is end with 6, but not a perfect square. 35 ends with 5, but it is not a perfect square. Next, if a number ends with the digit 1 or 9, then its square ends with the digit 1. Remember, if a number ends with 1 or 9, then its square ends with 1. Let us take the example in the first box, yellow color box. 1 square means 1. 9 square, 81. 11 square, 121. 19 square, 361. 21 square, 441. 29 square is 841. See, if a number ends with a digit 1 or 9, its square is always ends with the digit 1. Next point. If a number ends with a digit 2 or 8, then its square always ends with the digit 4. See the example? A green color box. 2, its square value is 4. 8 square, 64. 12 square, 144. 18 square, 324. 22 square, 484. 28 square, 784. So if a number ends with the digit 2 or 8, its square number is always ends with the digit 4. Next point. If a number ends with the digit 3 or 7, if a number ends with the digit 3 or 7, then its square ends with the digit 9. Let us take the example. Baby pink color boxes. 3 square 9, 7 square 49, 13 square 169, 17 square 289, 23 square 529, 27 square is 729. So if a number ends with the digit 3 or 7, its square number ends with the digit 9. Next one. If a number ends with the digits 4 or 6, if a number ends with the digit 4 or 6, then its square value ends with the digit 6. Light blue color. 4 square 16, 6 square 36, 14 square 196, 16 square is 256, 24 square is 576, and 26 square is 676. See the numbers which are ends with the digit 4, its square numbers are ends with the 6. Similarly, if a digit ends with the digit 6, if a number ends with the digit 6, its square number is also ends with the digit 6. So, for 1 and 9 ends with 1, for 2 and 8 ends with 4, for 3 and 7 ends with 9, for 4 and 6 ends with 6. Then what about 5 and zeros? See, if a number ends with the digit 5, its square number ends with 5, and if a number ends with the digit 0, its square number is also ends with the digit 0. See the examples of red and blue colors. 5 square 25, 15 square 225, 25 square 625, 35 square is 1225, 45 square is 2025, 55 square is 3025. So if a number ends with the digit 5, its square number is also ends with the digit 5. Similarly, if a number ends with 0, its square number is also ends with the digit 0. Some more note points about this one. If a number ends with the digit 5, its square number ends with 25. See, in all examples, till now, we learned only ending digit value for 5. But here, I am given last 2 digits. 5 square 25. 15 square 225. 25 square is 625. 35 square is 1225. 125 square is 15,625. 185 square is 34,225. So, if a number ends with digit 5, its square number last two digits are 25. And what about the zeros? If a number ends with 1 0, its square number ends with 2 zeros. If a number ends with 2 zeros, its square number ends with 4 zeros. So in general, if a number ends with n number of zeros, its square number ends with 2n number of zeros twice. See, 10 is equal to 100. So 1 square is 1. For 1 0, I am taking 2 zeros. 200 square, 2 square is 4. And for that 2 zeros in square, I am taking 4 zeros. 1500 square, 15 square means 225. And for that 2 zeros, I am taking 4 zeros. So observe the remaining numbers, remaining examples also. So, if a number ends with n number of zeros, its square number ends with 2n number of zeros. Now, some more interesting patterns. Here, the first one is adding triangular numbers. Do you remember about the triangular numbers? Yes. Here, numbers whose dot patterns can be arranged as a triangle. See, in the first one, 1 dot. In the second one, I am taking 3 dots. That 3 dots look like a triangle. In the third one, I am taking 6 dots. It is also like a triangle. And the fourth one is also triangle. Here, I am taking all the triangles are, so I am like equilaterals. So I am given 6 examples here. And for the first triangle, I am using only 1 dot. For the second triangle, I am using 3 dots. For third triangle, I am using 6 dots. Fourth triangle, I am using 10 dots. Fifth triangle, I am using 15 dots. Next triangle, I am using 21 dots. So here, if we combine two consecutive triangular numbers, we get a square number. Consecutive. See the first and second, if I adding first and second, together 4 dots. 4 dots means 4 means, is it a perfect square or not? Yes. Similarly, by adding number of dots in second and third one, 3 plus 6, 9. Yes, 9 is a perfect square. For third and fourth one, by adding, we'll get 16. Yes, 16 is also a perfect square. So, I conclude that in a triangular numbers, if we are adding two consecutive triangular numbers, then that result becomes a perfect square. Let us see this example. Same like 1, 3, 6, 10. I am taking 4 examples here. First one is 1 is a perfect square. By adding 1 and 2, see the color discrimination of second one. There are 3 greens and 1 red. Together 4, it is a perfect square number. For third and 6, by adding I am getting 9. See, there are 6 blue color and 3 green color. It represents the consecutives. And fourth one also. So, by adding two consecutive triangular numbers, we'll get a perfect square. The next one is numbers between square numbers. Numbers between square numbers. So, from 1 is a perfect square. What is the next perfect square? 1 square means 1, 2 square means 4. Next perfect square is 4. Next perfect square, 3 square, 9. See the yellow color boxes are perfect squares. The remaining white color boxes are non-perfect square numbers. How many numbers are lying between 1 and 4? How many numbers are lying between 1 and 4? Yes, 2 numbers. how many numbers lying between 4 and 9? 1, 2, 3, 4 numbers. How many numbers lying between 9 and 16? 6 numbers. So check the table. Here, number of non-perfect squares lying between 1 square and 2 square are 2, 2 square and 3 square are 4, 3 square and 4 square is 6, 4 square and 5 square is 8, 5 square and 6 square is 10, 6 square and 7 square is 12, 7 square and 8 square is 14, 8 square and 9 square is 16. So what is your conclusion? We conclude that the number of non-perfect squares lying between any two consecutive numbers is 2 times of smaller number. In the last example, 64 and 81, between 16 non-perfect square numbers are there. What is the 64th value? Is it 8 square or not? 8 square and 9 square. Small number is 8. 2 8s are 16. It's the previous one. 49 means 7 square. 2 7s are 14. Previous step. 36 means 6 square. 2 6s are 12. So, number of non-perfect square lying between n square and n plus 1 whole square means those are the consecutive terms is equal to 2 into n. N means among that 2 which is the smallest one. So, number of non-perfect squares between 20 square and 21 square is equal to 2 into 20. Here I am given 2 examples. Number of non-perfect squares between 101 square and 102 square is equal to 2 into 101, that is equal to 202. Similarly, 305 square and 306 square, 2 into 305 is equal to 610. Now, adding odd numbers. Yes, I am taking, what are the odd numbers? 1, 3, 5, 7, 9, 11, so on. Such type of numbers are odd numbers. Odd numbers means number does not divide with 2. If a number divides with 2, the remainder is 1, then such type of numbers are called odd numbers. So, first odd number is 1. Is it a perfect square or not? Yes. Second odd number is 3. By adding 1 plus 3 is equal to 4. Is it a 2 square? Yes. So, it is also perfect square. By taking 3 odd numbers, 1, 3, 5. 1 plus 3 plus 5 is equal to 9. Is also equal to 3 square. So, sum of consecutive odd numbers, first consecutive odd numbers is always a perfect square. If I am taking 5 odd numbers, remember that first 5 odd numbers. So, now odd numbers will start from 1 only. Sir, I am taking the odd numbers from 5 to 15, sir. 5 plus 7 plus 9 plus. But here I am taking 11 odd numbers, but I am unable to get 11 square. We can't get because we are not started from 1. So, if we started from 1, then only we will get an answer. So, sum of first n odd numbers formula is n square. If 2 odd numbers, 2 square. 3 odd numbers, 3 square. See the last one, last example, 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. Here, remember that here n is not equal to 13 because n means number of terms we are taking. Here I am taking 1, 2, 3, 4, 5, 6, 7 numbers. So, it is equal to 7 square. Here I am given examples 1 plus 3 plus 5 plus so on 15. So, here altogether I am taking 8 odd numbers from 1 onwards. So, answer is 8 square 64. The next example 1 plus 3 plus 5 plus so on 49. So, odd numbers from 1 to 49 are 25 odd numbers is there. So, the answer is 25 square, that is 625. So, the formula, number of odd numbers. How many odd numbers are lying? How many odd numbers we are taking? So, here number of odd numbers is equal to from 1 to 15. 15 plus 1 by 2, that is equal to 8 odd numbers. Similarly, from the second example, The highest one is 49. So number of odd numbers are 49 plus 1 by 2. That is equal to 25 odd numbers. So 1 plus 3 plus 5 plus so on, n numbers are there. Last odd number is n. Then number of odd numbers is equal to n plus 1 divided by 2. There are n plus 1 divided by 2 odd numbers. Next one, sum of consecutive natural numbers. Consecutive means side by side numbers. The consecutive natural number of 10 is 11. The consecutive natural number of 15 is 16. Consecutive even numbers means consecutive of 10 is 12. Consecutive of 12 is 14. Consecutive odd numbers means 9 is a number, its consecutive odd number is 11. Consecutive of 11 is 13. Consecutive means immediate number which follows the given rule and satisfy the condition. Here I am taking some examples. 3 square is equal to 9, I know that. I am able to express 9 is the sum of two consecutive numbers 4 plus 5. I am taking 5 square, that is equal to 25. 12 plus 13 is also equal to 25. 12 and 13 are consecutives. In 7 square, 49, that is equal to 24 plus 25. So 24 and 25 are consecutive numbers. So every odd square number I can express sum of two consecutive natural numbers. See, I am given one more example here, 99 square. The value of 99 square is equal to 9801. So that I am going to express as sum of 4900 and 4901. How I am going to get this 4900? It is 9801 minus 1 by 2, and the second side is 9801 plus 1 by 2. That is equal to 99 square minus 1 by 2 and 99 square plus 1 by 2. So every odd square number I can express sum of two consecutive natural numbers. Those two consecutive numbers, how to find? This is a formula. N square is equal to, if n is an odd number, n square can be expressed as sum of n square minus 1 by 2 and n square plus 1 by 2. See, down I am given the one more example. 21 square is equal to 21 square minus 1 by 2 plus 21 square plus 1 by 2. That is equal to 441 minus 1 by 2, 441 plus 1 by 2. That simplification will get 220 and 221, whose sum is nothing but 441. It is equal to 21 square. Next, product of two consecutive even or odd natural numbers. Product of two consecutive even numbers or odd numbers. The product of two consecutive even or odd natural numbers can be expressed as, so 11 into 13, both are odd numbers. That the number which is between of 11 and 13 is 12. So 11 I am going to express as 12 minus 1 and 13 I am going to express as 12 plus 1. So 12 minus 1 of 12 plus 1, it follows a algebraical identity. A minus b of a plus b is equal to a square minus b square. That is equal to 12 square minus 1 square means 1. Similarly, 13 and 15. What number lies between 13 and 15? Yes, it is a 14. So 13 into 15 I am going to express as 14 square minus 1. Because 13 means 14 minus 1, 15 means 14 plus 1. Similarly, 29 and 31. So it is equal to 30 minus 1 of 30 plus 1. That is equal to 30 square minus 1 square means 1. 44 and 46. It is applicable for both even numbers and odd numbers also. 44 and 46, the number is 45 minus 1 into 45 plus 1, that is equal to 45 square minus 1 square is equal to 1. So what formula is applicable behind of this calculation part? Yes, a plus b of a minus b is equal to a square minus b square. Yes, some more interesting patterns which follows a rule without finding actual actual perfect squares. Sometimes we are able to write the answer followed by a rule. See, 1 square is equal to 1, 11 square is equal to 121, 111 square is equal to 1, 2, 3, 2, 1. Here what pattern is follows here? If I am taking two ones, so the numbers I am going to write increasing order as well as a decreasing order from 1 to maximum number of numbers ones. It means if 11 square, 11 consists of two ones, so I am going to start the values from 1 to 2, again from 2 to 1. And 3 ones if I am taking, I am going to start from 1 to 3, 1 to 3 and again from 3 to 1, 3 to 1. Should not write 3 two times. If 4 ones is taken, 1, 2, 3, 4, 3, 2, 1. So increasing order as well as a decreasing order. It is like a shape of a hut. If I am taking 7 ones, 1, 2, 3, 4, 5, 6, 7, 6, 7, 6, 5, 4, 3, 2, 1. If I am taking 9 ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. It is a pattern. So it is very interesting. Without finding the original solution, I am able to write the answer. See the another pattern. 7 square is equal to 49. Okay. 67 square is equal to 4489. 667 is equal to 444,889. 66667 square is equal to 4444,8889. So what is the rule here? Here, if I am taking 7, that unit digits are 7. There, in first one, I am not taking any 6. In the second example, I am taking 1, 6. If I am taking 167, see here first number of digits. For 1, the square value I am getting 2 digits. For 67, 4 digits. 667, 6 digits. The number of digits are here doubled. Okay. If I am taking 5 numbers, definitely I am going to get 10 digits in its square value. In that 10 digits, see the example 1, 2, 3, 4, 5. Fifth one, 6, 6, 6, 6, 7 square. So here total 5 digits are there. Its square value I am going to get 10 digits. In that 10 digits I am going to divide into 2 groups. In first 5 group are 4s. 5 4s. In second 5 digits, 4 8s and 1 9. So, what is our conclusion? If this number consists 8 digits, 8 digits means 6s are repeated 7 times, 7 is repeated 1 time. Then its perfect square get 16 digits. In that 16 digits, first 8 becomes to 4. 4, 4, 4, 4, 4, 4, 4, 4. And the remaining 8 digits are 8, 8, 8, 8, 8, 8, 8 and 9. 7 8s and 1 9. So I hope you understood the pattern. So it is also one of the easy, but tricks are some little bit of difficult to remember all this. We are able to solve the problems if the tricks are remembered in the mind.